Master chemistry, the easy way.
Hybridization combines atomic orbitals to form new ones for bonding.
So it's like mixing S and P?
Yeah, creating sp3. Exactly, perfect. In the same atom, s and p orbitals combine to form new equivalent orbitals called hybrid orbitals. Why does hybridization occur? Let's add that to the board. It explains molecular shapes and bond angles. Why does hybridization occur? Let's add that to the board. It explains molecular shapes and bond angles. Why does hybridization occur? Let's look at the bond angles and the formation of sigma bonds. This predicts the geometry. Let's dive into types of hybridization. It depends on the steric number. That's bonds plus lone pairs.
Oh, I see.
All right, let's illustrate sp hybridization on the board. We mix one s and one p orbital to get two sp hybrids. Two hybrid orbitals in total. All right, let's illustrate sp hybridization on the board. We mix one s and one p orbital to get two sp hybrids. Two hybrid orbitals in total. For BCl2, the geometry is linear with a 180-degree bonding. Beryllium promotes an electron, hybridizing to sp for this shape. Ethene is sp hybridized. Why? Each carbon forms two sigma bonds. The steric number is 2, so hybridization is sp. Any questions? So, for ethine, the structure is HC-ref-CH. This triple bond is made of one sigma bond and two pi bonds. Let's look at sp2 hybridization. One s and two p orbitals combine to form three sp2 hybrids. This gives us three hybrid orbitals, as seen in ethine. So, ethine is sp hybridized, linear. Now, let's look at the geometry of BF3. It's trigonal planar with 120-degree bond angles. So, ethine is sp hybridized, linear. Now, let's look at the geometry of BF3. It's trigonal planar with 120-degree bond angles. Now, for example 1, boron trifluoride. Boron has a steric number of 3 sp2 hybridization to form a trigonal planar shape with 120-degree bond angles. Now, for ethene, each carbon has a steric number of 3, so the hybridization is sp². Let's draw the structure HCCH2. The double bond in ethine contains one sigma bond and one pi bond. The sigma bond is formed by head-on overlap, and the pi bond by side-on overlap to the Now, let's look at sp3 hybridization. One s and three p orbitals combine to form 4 sp3 hybrids. So, there are 4 equivalent hybrid orbitals. So, ethine is sp hybridized with linear geometry. Now, consider methane, tetrahedral geometry, 109.5 degrees. This angle is key for stability. Any questions? For methane, the steric number is 4. So, its hybridization is sp3. This gives it a tetrahedral shape with 109.5-degree bond angles. Now, let's move to our next example, ammonia. Nitrogen has 3 sigma bonds and 1 lone pair. This gives it sp3 hybridization and a trigonal pyramidal shape. For water, oxygen has 2 sigma bonds and 2 lone pairs. This gives it an sp3 hybridization and a bend shape with a 104.5-degree bond angle. Let's highlight sp3d hybridization. 1s, 3p, and 1d form 5 hybrid orbitals. This gives us a trigonal bipyramidal shape. For PCl5, we see different angles. In blue, the equatorial bonds are 120 degrees, and in red, the axial bonds are 90. Now, let's look at sp hybridization. 1s, 3p, and 2d orbitals combine to form 6 hybrid orbitals. For sp3d2 hybridization, we combine 1s, 3p, and 2d orbitals. This gives us 6 new hybrid orbitals. For water, the shape is bent with a 104.5 degree angle. Now, for an octahedral geometry, the bond angle is 90 degrees.
So, like a 3D shape?
Let's draw SF6. Sulfur has a steric number of 6, so it hybridizes sp3d score. I'll illustrate. Here is the octahedral shape. Let's look at SF6. Sulfur has a steric number of 6, so its hybridization is sp3d2. Let's summarize this. Here's a table to illustrate. For steric number 2, it's sp hybridization, linear geometry, and a 180-degree bond angle. Let's complete the table for other geometries. For sp², it's trigonal planar with 120 degrees.
Oh, right.
Let's highlight the key points. Sigma bonds come from hybrid orbitals, and pi bonds from p orbitals. Lone pairs alter angles, and more s character responds shorter and stronger.